Hello GCC Chem 107 students. We're here to learn about Chapter 7 on plastics. This is the first video on plastics from Chapter 7. So there is an assignment that goes with the plastics chapter. It's really easy. I want you to go online, look up your city, like Glendale City or Peoria, City of Peoria, City of Tolson. Search around on their website for the recycling program. It could be under waste management, trash removal, sustainability, or recycling itself. So just look around for it. Then I want you to type up a list of what your city recycles. Paper, plastics, what kind of plastics? Do you do glass, cardboard, newspapers? What kind of metals? What kind of cans? So look all that up. Then find out where you can recycle e-waste. That's electronic waste. What are you supposed to do with cell phones, televisions, computers, monitors, batteries, electronics, because those do not go in the trash. If your city doesn't collect them, then where are you supposed to take them? So you get 5 points for detailing what your city recycles and 5 points for telling me where you get the e-waste. Make sure you turn in your sources where you look this up, the sources, and I'll create a Canvas assignment so you can attach this paper as a PDF or a Word document, and I'll set up a due date for you. All right, so that's your recycling assignment. It's really easy. Just tell me what you can recycle in your city and what you do with the electronic waste. All right, so we're going to talk about polymers. Plastic is the general name for materials made out of polymers, which are organic molecules. Most polymers are made from petroleum oil. Remember when we talked about petroleum? It's a fossil fuel. Plastics are actually made from oil. So they're made from fossil fuels, and we have to drill to get the oil to make them. Polymers and plastics are really popular because they're easy to shape, they're cheap, they're versatile, and impervious to water, meaning they don't dissolve in water. Problems, however, are that they are non-biodegradable. If you burn them, certain ones release toxins, and right now they are filling up our oceans. We are becoming covered in plastics. They are labor intensive to recycle because you have to manually sort them. Machines cannot separate plastics 1 from 2, for example. You have to have people to do that. So it does create jobs, but it makes plastic recycling kind of expensive. No one's going to buy plastics from you the way they buy aluminum cans. Polymers are made from monomers. So if you look at this picture here, the polymer is the chain, the monomer is the link, one link. So basically we find monomers and we instigate a polymerization reaction, and that monomer will link to the next one, which links to the next one, which links to the next one, etc. for hundreds of thousands of units of monomer. So polymers are really, really, really big molecules because they consist of hundreds of thousands of monomers linked together. Now, most polymers are covalent. You need to know what covalent means. It means non-metal chemicals. A lot of polymers contain carbon and hydrogen. Those are both non-metals, so they are covalent compounds. Sometimes there's oxygen in a polymer. That is also a non-metal. So something containing C, H, and O's are covalent molecules. Polymerization is the process of making the polymer from the monomer. It's typically initiated by a catalyst, which can be very expensive. A catalyst is a chemical that helps the reaction proceed without itself being consumed. Thus, it's reusable. Catalysts are often very expensive, like I mentioned. So the catalyst can be reused, which is really nice since they're expensive. So you put it in a reaction, it gets that reaction going. When the reaction's done, you can filter, for example, and get the catalyst back out and throw it in a different batch. Here is a monomer at the top of the screen. We have a carbon single bonded to 2 hydrogens, then a double bond to another carbon single bonded to 2 hydrogens. That is the monomer. Monomers have double bonds. I have 3 separate monomers up at the top. The C2H4 plus C2H4 plus C2H4, and then it makes the polymer where it's all single bonds. So watch me for a second. Basically, when you have a double bond, it opens up and reaches for the next monomer, which then opens up and reaches for the next monomer, which opens up and reaches for the next monomer, and so forth. It just goes down the line real fast. So once you get that polymerization started, boom, all of those double bonds open up and grab onto another monomer, which opens up and grabs onto the next monomer, and so forth. I need you to be able to predict polymers from the monomers. I may do a little separate video showing you how to do this on a piece of paper, because I can't do that right now. So here are 4 monomers, for example: ethylene, propylene, vinyl chloride, and styrene. Now when you polymerize these, you make polyethylene, polypropylene, polyvinyl chloride, PVC, which you've probably heard of before, and polystyrene. Those are all big polymers. And the double bonds open up and grab onto another monomer, and it just keeps going. And I'll try to make a video showing you that with a piece of paper. So look for that video on polymerization. Quick review. Are the bonds in polymers ionic or covalent? I hope you said covalent. So let's see if you remember how many electrons are in a double bond. 4, right? Remember, a bond has 2 electrons. A single bond has 2 electrons, so a double bond would have 4 electrons. And I just answered the next question. How many electrons are in a single bond? 2. Remember, monomers have double bonds. Do polymers keep the double bonds? No. Remember, monomers open up that bond and to have single bonds only. Let's go through the first 6 polymers, the ones that typically can be recycled in some cities. Number 1 is polyethylene terephthalate. Let's just call it PET. And it has the little triangle recycle symbol with the 1 in it. This is your soft drink and water bottles. So there's a lot of polymer number 1 for all the bottles. All the Coke bottles, Pepsi bottles, Mountain Dew bottles, water bottles, all those bottles, whether they're 2 liter or smaller, they're all made of PET, number 1 plastic. What's really cool is you can recycle these bottles to make fleece, t-shirts, shoes, and carpet fibers. This plastic is transparent, meaning you can see through it, and it's pretty strong. The monomers are terephthalic acid and ethylene glycol. The polymer is a polyester, but don't worry about that. But just remember, number 1 is PET. I expect you to remember that. Number 1 is PET. Now this bottom picture is the monomer. This one's a complicated monomer. I would never expect you to draw this one. That big molecule repeats over and over and over again. So this is a complicated monomer, making a pretty complicated polymer. Number 2, HDPE. You need to remember that. High density polyethylene. Number 2, HDPE. Number 2. Uses. These are your really thick containers like milk jugs, shampoo bottles, laundry detergent bottles, bleach bottles. You typically cannot see through them. They are recyclable. We can recycle them and make crates and lumber and playground equipment. They're strong and durable and not transparent. The monomer you can see is very simple. There should be a double bond. It's already showing how it's opened up. So that unit gets repeated for the polymer. That's what the little N down there means. N can be 1,000. 100,000 of those units repeating. So that's just showing one unit of the polymer chain. High density polyethylene, number 2. Number 3, PVC. You've probably heard of PVC pipes, right? Those white pipes, polyvinyl chloride. If you look at the monomer, well, it's not the monomer, it's the polymer unit that repeats. You can see we have a chlorine in there, thus the polyvinyl chloride. It's a carbon with 2 H's, then a carbon with a Cl and an H. So we have a chlorine in there. And again, that unit repeats over and over and over 100,000 times to make PVC pipes. This is the 3rd most used plastic. The biggest uses is the pipes. Tile, vinyl siding, patent leather shoes, ducks. When we recycle PVC pipes, we can get flooring, notebooks, mobile home skirting out of it. There's a problem with PVC. It can release dioxin, which is a known human carcinogen. It causes cancer. That can be formed during the polymerization of PVC sometimes, or if you burn it. Incineration means burning it. So if you burn PVC, you can release dioxin, which causes cancer, so that's bad. A lot of countries have banned PVC toys because kids put the toys in their mouth. If it starts to degrade, it could release dioxin. So also, adult toys can be made of PVC as well. So you don't want to use those. No. Number 4, low density polyethylene. LDPE is number 4. You need to remember that. This is plastic bags. Wow, that's a big one. We have lots of plastic bags. You can't drive down the highway without seeing them floating around on I-17. They're everywhere. They're in the water, they're floating down your street, they're tangled in bushes, they're hanging in trees, they get stuck under your car. Plastic bags are everywhere. Number 4 is also bubble wrap, cling wrap, saran wrap. This one you cannot recycle, even if it's in your recycling bin at home. Even if it says you can recycle 1 through 6, it does not include plastic bags or bubble wrap. Don't put them in your recycling bins. Instead, take them to the grocery stores. Grocery stores, almost all of them have a big bin up front where they will collect your used bags and they can make more bags out of them. So the recycling uses of the plastic bags is to make more bags, 6-pack rings for Coke and beer. We can also make garbage cans out of them. This is a very flexible plastic. It can be transparent. It's not very strong. You can rip a plastic bag with your hands. So it's not a very strong plastic. So the polymer unit that repeats is down there. CH2, 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 infinity. So it just keeps going 100,000 times. But this is low density polyethylene. We'll talk about the difference between high and low density in a minute. So that's number 4, LDPE. Remember that. Number 5, polypropylene. Uses: plastic chairs like the ones you sit in class, diapers, Tupperware, benches, luggage, and carpet. This is the strong one. I always remember PP, polypropylene, is the strong one. It's very tough. You cannot rip a plastic chair with your bare hands. So number 5 is PP, polypropylene. It's the strong one. It is not translucent. It's opaque. That means you can't see through it. It's very strong, very tough. When you recycle number 5 plastics, you can make lawn rakes, ice scrapers, battery cables, things that are pretty tough and strong. If you look down there, you can see a section of the polymer. So we see CH2, CH, CH3, CH2, CH, CH3. And it just keeps going and going and going and going for hundreds of thousands of units. Polypropylene, number 5, PP, the strong one. And finally, we got number 6, polystyrene. Polystyrene has 2 forms. One is styrofoam. This is not recyclable. So this is packaging materials like what you see up there that may be packaged around a computer or a monitor. Takeout containers, styrofoam, cups, Those are not recyclable. Packaging peanuts, no, don't put styrofoam in the recycling bin. Even if it says plastics 1 through 6, styrofoam is not recyclable. So there's another version of polystyrene. It is regular polystyrene, and that is how we make up CD and DVD cases, plastic champagne glasses, disposable razors. Those are all the other kind of polystyrene, and those can be recycled if you can recycle number 6, polystyrene, PS. When you recycle those, you can make license frames, rulers, cafeteria trays. There's a picture of the monomer, and then you polymerize it, and you get the polymer. So we can see the polymer has this big ring thing around it with a circle in it. So that's pretty cool. So it looks like that. So remember, number 6 is PS. So again, you need to remember 1 through 6 and what they stand for. Good luck with that. See you in the next video.